Can you summarize for us the main points of your talk?
Sure. I discussed the gut-brain axis, which is the bidirectional communication system between the gastrointestinal tract and the brain, mainly consisting of neural pathways and humoral, mostly hormonal pathways, from the brain to the gut and the gut to the brain. And I applied this to a number of important phenomena. First, I discussed how these communication pathways can impact on gastrointestinal function and gastrointestinal symptom perception, particularly how stress and stress outputs from the brain can impact on barrier function of the gastrointestinal tract and mucosal integrity. And on the other hand, I discussed how emotional modulation of visceral afferent signals from the gut to the brain can influence perception of visceral pain in healthy subjects. The second part of my talk was on how hormones secreted by the gastrointestinal tract can impact on psychological processes in the brain. And I gave the example of how these hormones, particularly ghrelin, which is the hunger hormone, which is secreted by specialized cells in the gastrointestinal tract when people are fasted, how this can impact on reward processes in the brain, particularly dopaminergic responses to food stimuli. And then I concluded by showing human evidence that these hormones, like ghrelin, have a broader impact than only the regulation of food intake or food reward by demonstrating their impact on fear learning processes in healthy humans.
This is very recent research, and how do you think that this will impact on care for brain disease patients?
I think it's early days to talk about impact or therapeutic impact or impact for brain disease patients. We're trying to understand the basic mechanisms, often in healthy volunteers, but I think there is certainly promise for new avenues for treatment of brain-based diseases because of the emerging evidence that these gut-brain signaling pathways have a profound impact on all aspects of brain physiology, including the aspects I talked about today, which are mainly relevant towards psychiatric disorders. But there's, for instance, also emerging literature on how these signals, and again particularly ghrelin, may have impact on neuroinflammation processes in the brain, which could extend the impact of gut-brain axis research even further, not only including psychiatric disorders, but also potentially neurological disorders characterized by neuroinflammatory processes.
Thank you very much for this brief interview, Professor Van Oudenhove.
My pleasure.